meetup es en inglés, así que voy a hacer la introducción en inglés, por razones que algunos de nuestros emprendedores no hablan español. Bueno, muchas gracias por estar acá. Primera vez que lo hacemos en este hostal, que nos abrió las puertas, así que primero también gracias a los que dueños del hostal. Y estamos todo el tiempo tratando de cambiar el formato, hacer más entretenido, diferente, etcétera. Creo que ahora a la tarde puede ser que abran un bar acá atrás, así que ojalá que eso funcione. Y eso. So, again, welcome everyone. We're trying to do like always different kind of format for our meetups, so that's why we change places. It's first time we do it here. I hope you guys enjoy it, and this time we have one of our entrepreneurs from round 7, right? You just got to till like in 1 month ago, right? Yes. And it's gonna talk about like application, building an application, and I know you're gonna also mention some programming language and everything, okay? So just like, thank you for joining us, and you can go. Thank you.
Thanks, Carol. I think, do I need to use mic or everybody can hear me?
It would be better to use the mic for the video.
Hi, can everyone hear me? Oh. Hello? Is it audible? Okay. Hi, my name is Riddle. If that sounds twisted, I mean, you can use Arya. It's much easier. I'm founder and CTO of Centropy. It's an online fraud detection and ID theft detection service. During this application and my previous years, what I'm presenting here is from my experience in past 10 years. We are going to cover a bunch of things, basically how we go about building a web application and how we scale it to accept a lot of user traffic. So it's going to be a very interactive session, so if you can wait till the end for the questions, or you can stop me at the end of the slide if you have any questions there. So first thing, when we are talking about why not building scalable web applications from the beginning. Most of us start from, most of us are very bootstrapped. We start from small base and then we go up. So we cannot have resources all the time to invest into building very large scale applications. So the idea of this talk is to present what are the minimum things we should start with for the applications we can scale, and I mean the minimum things which should be kept in mind. So what are we going to cover is how to go about building an web applications, which problems to identify, then how do we go about scaling, and I'll explain about some tools which are to be used during this process. Now, what's not about which technology or which stack do we use. Of course, I'll be very welcome to answer any questions regarding this. It's not about best practices of any particular language. It's not about optimizing your web application. It's not about optimizing the or configuring the database. Now, when building the application, these are things we are going to see: which technology, frameworks, sessions, assets, caching. Actually, I took this sessions part out. Okay, anyway. So technology wise, whichever stack we use. So a lot of people say Ruby is best, or Python is best, PHP, whichever is easier. But thing is, everything has a learning curve. Everything has some problems. In some fields, few of the things are better. In some cases, you invest more in the beginning, that you hire very experienced developers. You put in more in infrastructure. In some cases, like let's say PHP, for example, you can start with very, very small resources. So another thing is when we start, we have to also look at maintainability. Like the application which you are developing should be simple enough for new developers to take up, for a system admin to manage, and so one of the main advices I have here is like sticking to open source stacks to start, where the cost is low. You have a lot of community support to start with. Next is, I'm sure everybody is using some kind of framework to start with. In many cases, like Rails and Django, I mean, these are the primary reason why people pick up Ruby or Python altogether. In PHP, you have a lot of options, but the main advantage is most of them follow MVC. Most of the best practices are followed with these frameworks. So, I mean, it's a good choice to go with a framework. Even if you don't pick up a open source framework, it's okay to create your own lightweight framework, which has the basic things like session handling, database query builder, etc. Now, and of course, another advantage is each of these frameworks have a very good community where you can get a lot of supports if you get stuck. Next thing is sessions. When building the application, you have to be mindful of how you manage sessions, because using just the file system sessions, and later on if you move to bigger infrastructure, it will be difficult to manage. Like, let's say if you spread up your infrastructure to a lot of web servers and you have a load balancer. So in that case, when the load balancer switches a user from one web application to one server to another server, it will not remember what was the session, because sessions are stored on the file system and it's sticking to the one particular web server. So the other ways to manage is database, which is easiest to go with. You can start with from the very base to have this in database. And the other one is memcached. That is, I'll come to that later on how to manage that. Next thing is assets. Assets is our images, JavaScript, CSS, these kind of files which are mostly static, which do not require any kind of processing from Ruby or PHP. So and these can be directly loaded from the application. So the best way is to manage is that we create public folder where it can be accessed directly, and even if you're loading it dynamically, it should appear to a user as if it's coming from via direct request. For example, if let's say you have JavaScript files, so usually now most of these frameworks where you have already a foundation where everything goes into public JS, CSS, etc. So one good idea will be to make this configurable, where you define your asset path, and when you load, you load as load.js, and you define a JavaScript file. So I should have put some examples. I'm sorry, that would have made it clearer. Now this will have an advantage later on when you switch to multiple servers. You can split your file, these assets server to a different server, which is just having let's say your JavaScript and CSS files, and your requests are directly going to that server and it's not going to the main web application server. Now one of the things which can be implemented early on is caching. The easiest to start with is file caching. Like you take your page, whenever it's processed, you can just take the snapshot of that page and put it as HTML as cached. So your language interpreter, PHP or Ruby, doesn't have to go through executing the whole code, and it can just pick up the direct HTML. Then we have in-memory cache. Again, on this I'll come back again, but basically a lot of things you can put, like sessions, objects, your query results. Like for example, if you have a discussion board where you can keep in what are the permissions of users, that can be cached for a particular user. It can be kept in a session, and it can be cached. So every time when the user refreshes the page, you don't need to go back into the database and check what is the permission for this user. Or it can be as simple as like what are the posts on the first page. So as long as you don't go and make any changes, or new posts are not published, you don't need to make any changes to the cache. So another thing is pages and fragments. So one problem a lot of people face is when you have a user application where you say like logged in user and you show his name. So if you're caching the whole page, the problem will be that everybody will be seeing the same page, and every time it will be actually an invalid cache because everybody will be seeing the same user's name there. So in that case, you can cache the fragments, which is same for everybody, like page titles. Then you have the common sections, the name parts where you have users' messages that can be separate. Then we come to the database. So first thing is schema design, like keeping a common convention where you name the fields, tables in a proper way, define the data types properly. Then selecting the engines. I think everybody here uses MySQL, so people go for InnoDB. There are some other advantages if you use MySM, but that is for specific cases. So you have to see which particular use case will be applied on a particular table, and you define that kind of engine for that. Then we have normalization, which is like defined as basic for any RDBM, is that we have to normalize the database. This is, I mean, it's not always necessary to do that. For example, in Syntropy, we have a lot of data which is stored in a key value format, and if we go to read everything from that table, it will be a very, very high load scenario for that particular page. So what we do is we take out some parts of it and put it in a in a row format, and that makes it easy for people to view visitors log data like that. Then we have profiling, which is seeing what kind of queries, what kind of load is put on the server. And in MySQL, there's one very good statement which is explain, which shows exactly how the query is executed. So when you use explain, it will show you which index was scanned, which fields were accessed, and where it was inefficient. Then it's very important to log the slow running queries. So basically you should start with 1 or 2 second queries which are heavy and start optimizing those. Then one of the major things or mistakes people do is they pull in some amount of data from the database and then loop through it and then request again to the database for some partial data. So it's better that all kind of sorting, all kind of conditions are executed in the database side itself. Put everything in your query, execute it on database. That's the most efficient way. That is what it's built for. Any of the programming languages, they are not the best for doing any kind of sorting or this kind of activity. Last thing is ORM. I think most of the frameworks we use, they have ORM built in, and most of the time we start with it. There are some problems with it. We'll come to it later, but starting off, it's completely okay to start. Now, when our application starts picking up some traffic, and we for the first problems we see is users complain of slow page loads, timeouts, nothing works for them. And if you're monitoring your server, you'll see a lot of load by the MySQL process or your language runtime, which is PHP or Ruby or Apache, whatever. If you're not looking at even that, you'll see on Google Analytics that there are a lot of there's very high bounce rate. So at least one place to find out where the traffic is going. Now, the quick fixes you can do is first thing, upgrade the server whenever this kind of problem happens. You split the database and web servers, you put them on different servers. That's one of the easiest way to go. And to install a reverse proxy, which is caching some of the elements like your CSS, JS, which doesn't need to be processed by Apache. I'm sure most of us are using that as our web server. Now coming to scaling, these are the things we are going to cover. I'll go through these points one by one. So horizontal and vertical scaling. Basically, horizontal scaling is where we put a lot of similar machines, which is like the cloud kind of scaling, where you put in a lot of nodes, and these nodes are all similar. They have same kind of configuration, like having a farm of a lot of web servers. Then we have vertical scaling, where you just upgrade the specs of the server, like RAM or CPU. So this can be done by increasing the size of the instance or VM instance, or you could just upgrade the physical server. But there's a limit to that. This can be a temporary fix, but in longer run, you need to go for horizontal scaling. So the first thing when we are going to scale, we need to have enough data to see where we are going with this. So we need to do some kind of load testing on the application to see where is it failing, what are the limits, and when we add more resources like RAM or CPU, how far can we go with it. Apart from this, we also need to look at logs, which one of the primary things is application error logs, where the application is failing, you have some problems, and database error and query logs. You also need to look at the server, on the server, that what kind of resources are being used, like your RAM or CPU utilization, to what level is it going. So that is something you have to look into it constantly, at least once in 24 hours, that what kind of spikes did you get. One of the best things we have right now is a service called New Relic. Has anybody heard of it? New Relic? Okay. So this is available for PHP, Java, Ruby, most of the languages. And basically this, you integrate it with your server, and this will profile the application for you. It will tell you where your application is slowing down. And the best thing is it has a free tier. So for 24 hours, the data is retained, and you can, without paying, you can take a look at how your application is doing. Now then we come to the architecture. If I'm going very fast, please let me know. So the architecture, like most of us are hosting in the cloud, either it's Amazon, Linode, or Rackspace, or one of the deployments we are using, it's a hybrid model where we are using dedicated machines as well as VMware ESXi to manage the actual web servers and database servers like in a cloud kind of environment, but that's controlled. That gives us advantage of tweaking and allocating more resources to a particular server when needed. So basically this is how your application will evolve. We'll have a web server. When we split it, we go to a web server and the database server. This will ease up something, because what happens is the database and web server, they scale in different ways. Sometimes you'll have a lot of load, depending on your application, how it is, a lot of load on the database, but after some time, when your query cache is built and your application starts responding smoothly, it will go in a rather horizontal manner. But after some time, you may have load from the web server itself. So separating both gives you advantage of managing them differently. You don't have to fight on the resources. They don't have to fight on the resources on the same server. Then the other server I spoke of was file server, where you split all the static content, put it away, which doesn't need to be processed by Apache. Then the next phase is where eventually there'll be load on database, and what we do is we keep one server where all the data is being written. Is it visible? Okay. If can I speak from here? Is it audible? Okay, I think this is better. So what we do is we have a master SQL server, SQL database, and all the writes are going to that database, and it's being replicated to a lot of slave servers, where which gives us advantage of when the read operations happen, because in most cases 90% of the operations on any application would be read, unless it's a very transactional application. So it gives us the advantage of reading everything from these slave servers, and the master server takes care of replicating all this data from that server to slaves. This is the next stage, where we move down. We have multiple web servers, and we have a replicated database server. So now there's not limited that it will be only 2 servers, depending on how many what kind of load do you have on your web application or your database side. You can change this. Now, when we come to scaling the web server part, now again, all these components have to be managed individually. So we have a question of selecting which kind of web server works best for whom. So generally everybody starts with Apache. A lot of people move to Nginx to see better performance. The advantage Nginx has is like it accepts a lot of connections, so you can increase the number of users you can handle very quickly if you just switch to Nginx. But again, managing Apache is rather easy, so a lot of people stick to Apache for that reason. Then we have something called light HTTPD. So in this, this is a very lightweight web application server. So in this case, this is suited more for serving static files. So if you have your JS, CSS files, images, you can just put it back, put it on that kind of server. What happens in Apache, if we are serving static files, it has an overhead when you're using any, let's say mod PHP or mod Python. It has that kind of overhead. Light HTTP that doesn't have. You can minimize that part. Then one good thing we have is putting up a reverse proxy. So it's like a normal proxy which we use in our network, where a lot of content is cached, and when users request something, it's served from the local network and not from the remote server. So in this case, what happens is, if let's say we put Nginx or Varnish server before Apache, so all the requests which are going to Apache eventually, so it takes up all the JS, CSS, any kind of static file, and caches it on Varnish or Nginx, and it's directly served from there. So Apache doesn't have to process all that. It's faster, much more optimized. This thing I've already spoken of, offload static content. So for example, what we can do is, I think, has anybody used Wiseflow to track why their site is slow? So one of the main things you get is CDN, like you're not using a CDN. So if you're separating your static content from main application, so in that case, what you can use is you can fake this kind of activity. For example, if your assets folder, you put it on separate server, and then you can use subdomains which are pointing to that particular folder. So you can have like images.yoursite.com, css.yoursite.com. Basically what it does is, usually when you request something from a server, you have 10 threads which can get all these files. So if you have included a lot of CSS and JS files, it limits till you have these 10 files downloaded. It won't let you request next 10 set of files. But if you name your servers like images01.yoursite.com, browser considers as a different server. So you can parallelize a lot of browsing from the server. Then we have, this is small configuration which is required. This is code accelerator, basically whatever PHP, APCs for PHP, Cycle for Python, and Join for Ruby. So the code which is being executed, that is converted into opcode and kept in memory. So whenever the execution takes place, it doesn't read through the file and execute all that. Then the last thing here is splitting the session server. We earlier I spoke of sessions being in database or as a memcache server. So we put the session server separately, and what happens is, even if we are using multiple web servers, in that case sessions information is being accessed from only one place. Now we have the database server. So first thing is to identify the slow queries, identify it from the slow query log, and we have to optimize those queries. Next thing is ORM. We have to deal with it finally, because it generates a lot of overhead when the queries are built from ORM. So it's probably better to write plain SQL queries instead of using ORM. Then we have a problem of connection overhead. So we have to be mindful in our application to get everything we want from our application in one request. So if in a single page load we are requesting data multiple times, it forms a new connection every time. It's a lot of overhead, so it's better to get everything in one request. For example, if you're loading data about some people, so some people tend to get people's IDs first and then request individual row data from that, so that's not optimized. Then get into real database side, which is partition. We can choose to partition data to get better, faster access. So partition actually works, separates the data. It's like arranging books in a library. So when you're looking at A, so you know where exactly A is, and the index for that particular partition is stored differently. So it gives much faster access. Replication, you'll have to address this to expand your infrastructure, that data is copied onto multiple servers where the read operations can take place. Now the last thing is caching. MySQL has its own query cache, so which allows, let's say, whenever query is executed, at that time it creates a hash, and whenever the next time the same query is executed, it will pick up from that hash, so it doesn't have to go through the whole execution scenario. But as soon as anything in the table changes, this query cache is invalid, so it has to create the cache again and again. So one good way to do it is memcached. For example, let's say if we are requesting some data, we can take this. Okay, actually, sorry, I should come to memcached first. It's a caching mechanism, so which allows us to. It's a very small application, runs as a daemon on Linux servers, and basically we can cache different kind of fragments, data into this server. So this data, whatever, let's say if we have a user's information or session data or a lot of posts from a forum, so we can cache all that, and until that changes, we can keep the cache as it is. I think I'll just skip this load balancing. We are kind of out of time. Okay, so a few things which we skip when building the application. We forget the search, that the application has to have a search. Change few things to adjust or speed up the application. This is when you have low number of users, it's okay, but when you have let's say a lot of users online and everybody is trying to send a mail, and your script has actually to wait to send information to SMTP server that okay, send this mail, and it has to wait for a response, and this creates a problem because it's not executing further. So one good way is to implement a asynchronous mailing mechanism where your application just sends the mail, or keep it in a database where it can be scheduled to send out. Further on, we can go with DNS servers and failover and disaster recovery. This is like very advanced topics. It has to take its own time. Now, some resources. New Relic, I told you about this. Loader.io, this is an excellent tool. This is a web application. Basically, you can go there, you can put in your application name and your URL, and you go on specifying that what pages it has to go in. You can even specify that it has to log in into your application and what other pages it has to access. So, and it gives you very good benchmark. It simulates a lot of connections from different servers. So gives you very nice chart of where your application actually started failing. At 100 users, 200 users, you can define how many steps you want to go on, like add every 50 users every second, and to what extent your application was able to process the user requests, and what was the page response time. Like when we start, the page is very fast, but when a lot of people come in and everybody is fighting for the resources, so things start slowing down. Well, the simplest tool to use is AB, Apache Benchmark, and Apache has another tool called JMeter. It's a bit complex, but you can specify a lot of options, like let's say if you want to simulate user signups, so you can tell it to write a script to fill up user forms and simulate the whole process. Then on AWS we have something called bees with machine guns. So this is you just specify your AWS key, and it is a Python script. So this starts a lot of different instances of AWS machines and starts attacking your application with lots of connections. So, and gives you very good insight on how's it doing. Then we have write scale. This is further on when you want to manage your application in a real world scenario. This will allow you to automatically create new instances of your application, replicate them, and scale your application as per user demand. So if a lot of people are using your application, you can just keep on adding more VMs. Then one of my favorite is PubNub. Let's say when you have an application which has a mobile interface and a web interface, and you want to do a lot of message passing, which should be very fast. So this is you can just outsource it to PubNub. It's much easier. For slow query logging, this is a very good tool. Not for slow query logging. This MySQL tuner. It tells you where you need to improve your MySQL server configuration, how your index is doing, and which configurations you need to change, and it gives you good recommendation as well. ActiveMQ and ZeroMQ are daemons which will allow you to set up a queuing system for your mails for different kind of jobs. This is very essential if you're going to have a lot of users, which will be sending out a lot of mails to users. Okay, thank you everyone. I hope I didn't go too fast to understand. I mean, you didn't have any problem understanding. I'm open for any questions. No questions? So that sounds bad.
Very good.
I hope you liked it. I mean, I had something. So these are a couple of topics I can cover next time if somebody is interested. One is secure software development lifecycle. This is good if you are developing application like any kind of government agency or which has sensitive user data. This will allow you your software to be PCI compliant very quickly. And other thing is more about databases. If you want to discuss about selecting which kind of database is good for you for now or for future, we can cover that. Okay. Thank you. Thank you, everyone.
All right.